So this is today's Leetcode problem of the day, which is 840 magic squares in a grid. So this is marked as a medium problem, but I think it's an easy problem. Let's see what the question says. So question first of all defines what is a magic square. So this defines a magic square as a 3 cross 3 grid which is filled with distinct numbers from 1 to 9. So 3 cross 3 means the size of the grid would be 9, or the total cells in it would be 9, and it says that each value from 1 to 9 should be in the grid, such that each row, column and both the diagonal all have the same sum. So like here, if we see this subgrid, this is a 3 cross 3 subgrid, and each value from 1 to 9 is there, right? So 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6, 7, 8, 9. Now each row sum and each column sum should be same. So like this row sum, here it is 15, right? So this row sum should also be 15, 10, 15. This row sum should also be 15, which is 15. This column sum should also be 15, and we can see that it's 15. This should also be 15. This should also be 15, and the sum of the diagonals. So this 3 plus 1 plus 2, that is not 15. So this is not a valid subgrid. What is a valid subgrid? We can see here this is a valid subgrid. So yeah, here the sum of a row is 8 plus 4, 12, 12 plus 3, 15, it's 15 again. But the diagonal sum is also 15. So 4 plus 6 plus 5, that is 15. And 8 plus 2 plus 5, that is 15. And if we look at the constraints, so the constraints are very less. The grid is of very small size, even if it was of big size. So big size means that n cross m is around 10 to the power 6, n into m. Then also we can use the solution that we want. So how can we solve this? It's pretty simple. How can we solve this? Like what we need to do is check for each subgrid of size 3 cross 3, is this valid or is this not valid, right? This is what the question asks. So let us take the first subgrid of size 3 cross 3. So size 3 cross 3, then first check that we need to do is each value from 1 to 9 there, right? This is first check. Then the second check is that is row sum equals to column sum equal to diagonal sum. If both of these conditions are true, then we'll say that, okay, this grid is a valid subgrid, and then we can move to the second subgrid, right? So this is what we need to do. Now we just need to get all the subgrids of this size 3 cross 3, sorry, all the subgrids of size 3 cross 3, check if they are valid. If they are valid, we can maintain an answer variable, which is the number of subgrids. We can do answer plus plus, else we'll just remain our answer as it is. So yeah, pretty simple. Let me show you the code. So here, first of all, I am getting all the subgrids of size 3 cross 3. How we are doing this is, see, all the subgrids of size 3 cross 3 must start from, if there are n rows and m column, must start from between 0 to n minus 3 and between 0 to m minus 3. This is similar to like if I say that I have an array and I need that the size of the subarray must be 3, then the values must start from n minus 3, right? Because if it starts from n minus 3, the subarray could have n minus 3, n minus 2, n minus 1, these indexes, so 3 indexes, right? Which makes sense. If it starts from n minus 2, the max value it can have is only 2 values. So this is fine. If this is fine, then similarly for subgrid, if I want 3 cross 3 subgrid, then the starting cells should be at max this n minus 3 or m minus 3. If it is more than this, then the subgrid cannot be of size 3 cross 3. So this makes sense. Yeah. So that is why I'm iterating over 0 to n minus 3 and 0 to m minus 3. I get my subgrid. How I get my subgrid is just from this ij, this is my first cell. So I just do I plus x and j plus y. This is pretty intuitive. Like if this is my starting cell, then the first grid of the like this of the subgrid I create of 3 cross 3 size, right? So subgrid 0 comma 0 should be I plus 0 comma j plus 0. Subgrid 0 comma 1, this is that cell should be I plus 0 comma j plus 0. So j is 1, right? So 1 plus 1. This makes sense. Then you just need to do is magical check. So is magical check on the subgrid. If this returns true, answer plus plus, and finally we can return the answer. So now all we need to implement is the is magical check. So first of all, the check should be that each value from 1 to 9 should be there. So how we are doing this is that we are maintaining a their vector, which basically will have that their x equals to 2 is basically that this x is in the grid. So initialize everything to false. I go over all the cells in the subgrid. I check if the subgrid's value is less than equal to, we can say less than 1, right? Less than 1 or greater than 10. or greater than equals to 10, so it is not in the range 1 to 9, which the question says the each value of the subgrid should be, then we can just return false. Or we can even check if the grid value is already present, because if that value is already present, we have two values that are occurring together, and these will not be distinct. Like if there are two ones in the grid, then the one is not distinct, so we can return false, else we will just mark it as true. Finally, we just need to now check the sum. So how I am implementing it is, first, because see, I need to match my two diagonal sums. So this diagonal sums and this diagonal sums. So first check that I will do is I will just calculate my diagonal sum 1. This is one diagonal, and this as diagonal sum 2. Now the cells on this would be of form I comma I, right? Their row and column would be same. The cells on this column would be of size I comma 2 minus I, right? Because see, this is 0, 1, 2, so this would be 2 minus 0, then this would be 2 minus I, right? So 1 comma 1 and this. So yeah, we can see this property, and you can even remember this property. But yeah, if you solve like a, because see, every cell of this diagonal has to have this property of I plus j equals to n. I plus j equals to n minus 1. Yeah. So I plus j equals to n minus 1, and we can even see this n here, basically the size of the subgrid, which is 3 here. So that is why I plus j equals to 2 and j equals to 2 minus I. Right, this makes sense. Then finally, I just calculate my diagonal sum 1, diagonal sum 2. As I said, diagonal sum 1 elements would be of form I comma I. Diagonal sum 2's values would be of 2 minus I comma I. Or you can say this as I comma 2 minus I also. That doesn't make much of a difference. So now I will check that is both of the diagonal sums equal. If they are not equal, I will just return false, because every sum has to be same. Now if it is equal, then I will calculate for each, I will calculate the row sum and column sum. I am calculating it together in one loop. Okay, sorry. So yeah, similarly to how we did for diagonal sum, we can also do for row sum. So like when we are calculating row sum of this, we can also calculate the column sum of this, and this row sum should be equal to column sum, and row sum column sum should be equal to diagonal sum. So I go over all the cells. The row sum would be grade ij, and column sum would be grade ji, because I'm iterating over j, right? So if I want to get the row sum of this, I will just iterate in the form I and j from 0 to n minus 1, which is 0 to 2. If I want column sum, then I will just do j I and iterate over j, basically keeping I as constant, and iterate over j from 0 to 2. 0 to 2, sorry. Yeah. And finally, I will just check if row sum is not equals to diagonal sum 1, or column sum is not equals to diagonal sum 1, then return false. Else everything is equal, we'll continue. And finally, if for none of these times we return false, then the grid is valid and we'll return true. So yeah, this works. Thank you for watching. If you were able to understand something and like the video, give it a like and subscribe, all of those things. Bye.